Today we're going to be looking at some function modelling, and we've already done a bit of this in our investigation, so this again is a bit of a review of some of the stuff we've already done. So here's an example of strawberry plants are sprayed with pesticide fertiliser mix. The data showing the yield of strawberries per plant for the various spray concentrations per litre. So first thing that we want to do is generate a scatter plot of our data. So what you need to do is you need to go to your calculator. Alright, so if we go to our calculator and we need to go into Scatterplot. Now I've got some data in here, number one, so I'm going to clear that by going up to the top there and going clear, and then we're going to have to put some data in the top bit there, and again clear the list, and that will get rid of all that data now in there. So I'll just put my values in, so they are 0, 2, 4, 5 and 8, so not a lot of data into our model. And then the other values are 8, 14, 19, 22 and 30. Alright, so looking at that, now the next thing we want to do is we want to graph that information. So if we go to second function Scatterplot, mine's still on, yep. So coming across to here, it's on. I'm going to go to that particular data, Scatterplot, choose list number 1, that's already chosen, and I have to change that to list 2. Alright, and then once I'm happy with that, I can go to my zoom button, and remember it's zoom 9 for StatFit. Now I've got another function on there, so what I have to do is go and turn, I'll just delete that. Alright, and so when I graph that, I'll get a function there. Now, looking at what that function does look like, we have some models that might fit. Alright, so keep in mind, we're going to work our way through those systematically. So, what other models that we'd be looking at? Well, that'd be the ones that we've been talking about. So we could go to our stat, go to calculate, and the first one we'll be looking at is number 1, which is a linear model. Alright, so we change that to list number 2. Alright, and then what we'll do is we'll put that into our Y1. Alright, so if we graph it, then we can get an idea about what that might be. Now, if you don't have your correlation coefficient come on with that, and that's saying that's a very good correlation, 0.99 is a very strong correlation, then what you need to do is you need to go to your catalogue. So if I just quit out of there, I'll show you how to do that very quickly. Alright, so you go down to 0. Alright, now the quickest way to get down to the diagnos on is go alpha D. I seem to have to do it twice for some reason, and then scroll down to your diagnos on, enter, and then you can go to your stat button and do the same thing you just did there. Go down to number 4, which is a linear one. Everything else is pretty well done. I won't type the other thing in there again, but if I go calculate, it gives me my model and also gives me my correlation. So you can see that's quite a good one. I graph that, will show my data going through there. Quite a strong correlation. You'd probably be thinking that's a pretty good model for that. Alright, so that would be certainly one that you could write down. Just quit out of there. Right, and just bring the last thing we did up. Right, so if I want to write down what my model is in fact a linear model. 2.734 x, and that's going to be 8.212. Right, so if I'm looking at my particular question that I've got, right, so generate a scatter plot, yeah, I've done that. So what are the possible models that can be eliminated? Well, the issue is it's saying when x is equal to 0 that y is equal to 8. Okay, I think that means that you cannot have a power model. Alright, so I can just quickly show you that. If we go to a power model, go to stat calc and come down to the power model. Alright, so the power model's got to go through 0, doesn't it? Okay, so list 1 and 2, and come down to calculate, enter. Alright, doesn't work, does it? Right, so we can eliminate the power model. That's the one that we can eliminate. So if we go back to our question over here, so for each of the remaining models, fit a curve in each case and the value for the coefficient of determination. So what I'm expecting you to do here is in fact to basically give me the R-squared value for each of these. Alright, so in part B, we're going to say we can eliminate the power model as it doesn't go through the origin. The power model's got to go through the origin. Part C, so the first one we got there is R squared. Actually, I should write the linear thing first. Right, so what you do, this is being systematic with this, so you go linear. You don't have to state the model yet. So R squared is equal to 0.99, what was it again? I can't quite remember. We'll go back to the calculator. I'll go back and do that again. It doesn't take long. So 4, it's all set up. So just scroll down and calculate. Okay, so we're really interested in that. So it's 0.993. Alright, so give 4 decimal places with these. Alright, so the next model we can choose, it's really quick to do this. So you go start. We might think it's a quadratic. So we'll go to number 5. Alright, everything is set up there. Won't worry about graphing it. Just go calculating because I'm interested in my R squared values. 0.995. Okay, so looking at that, so my quad R squared is equal to 0.9994. You could try your cubic model. So again, start, come across to calc, number 6. Right, come down to calculate, enter. That's giving me 0.997. Right, so that's even a better correlation. So cubic R squared is equal to 0.9997. Keeping in mind all of these are pretty close to being perfect correlations anyway, so I wouldn't get too worried about that last decimal place. We'll scroll down to the other ones. Okay, so it might be that it's an exponential. Right, so we'll try that one. And to calc, that gives us a R squared value of 0.94896. So we'll round that off to 0.9490. So R squared is equal to 0.9860, and that is for the exponential model. And then the last one we might try, well, we don't have to try the power one because we know that doesn't work. Alright, so that's pretty well all our models that we can look at. So we've done that part of the question, and then it talks about studying the equation, the function, and line the best fit from the function over there. Now, even though all of these things here pretty well give us a linear correlation, what I'd be thinking is, for this one here, that it may be something like an exponential model might work, or maybe even the quadratic model, because it may mean that if you keep putting more fertilizer on there, right, you actually kill it off. Okay, so sometimes too much of something is not great. So any of those models would be fine. Now I'm just going to go state the linear model, if that's alright, just to show you what we're expecting. So in part D, in part D we're just really expecting you to write down the model in terms of the information you've been given. Right, so we've been given our y value. Right, normally you'll have terms for this, so y is equal to, in this particular case it's equal to, what did I write that down? It's equal to 2.734x plus 8.212. Alright, so the idea is you're writing down what your model is, right? And generally what we would have is we would probably have things like, if we were doing that for real, and it's probably poorly set out this question, but you might look at the number of strawberries is equal to 2.734 times by the concentration of the fertilizer that you're putting on there. Got the idea? So there's some steps to go through with these questions. I don't think we're really doing anything new, but you need to be really systematic with all this gear here, right? So all of this gear that we're talking about, be really systematic, just list it down, ask squared values, and then you pick your model from that afterwards. Keeping in mind, you know, with these ones in particular, the quadratics and the cubics, we know the cubic has 2 turning points, and we know this has 1 turning point. So you need to be aware of that. Now, in this particular one, it might be the quadratic model might have been a good one. All right. So anyway, you can make the choice, and you base it on your R-squared value. All right. So good luck with those questions. Not hard. Just a bit of practice of what you already know how to do.